Sophia, did you find your group? Okay. Hola mes amis, bonjour, comment ça va? Come on, who are you guys missing? So when someone comes in late, we know where to go. There it is. Here's your other member. Back there, group 5. Everybody else, do you have all of your groupies? Drawer. Oh, you're missing.
Chrissy.
Okay. Okay, so. All right, guys, here's the deal. By Wednesday, you need to be really good at the problems that are on worksheet 1 and worksheet 2. We will have a quiz on Wednesday that is basically 2 sides. One of them, hey, graph this. And maybe you need to calculate a slant asymptote. Some eyeballs just went, what? And there's something missing here. What's coming up? Quiz on Wednesday. What's on Friday?
District.
The district assessment. How much does the district assessment count in your grade? 10%, not 20. Back off. 10%. And it is on a county created curve. The issue is they can't create the curve till I enter the scores that you guys got. So I can't tell you what the curve is right now, but I can say if you know on leaving, I know I got those 3 wrong. If you know you got a 7 out of 10, your grade is at least a 70, but probably higher. So the way curves work is like it might be a 75, or if it's a really horrendous thing, it might be an 85. The curve for all these people that are on the wall of fame for getting a 5. Hello, BC Calculus people. What is the percent that you need on the exam to get a 5? 60? Like a 58 or higher. So 58%. That's not passing when you get on the wall because you get a 5 and you get college credit. So there are some curves that are pretty wicked. AP. The county curve is not going to be that wicked, but there will be some kind of curve. So don't panic when you're taking the test and you're like, I don't know how to do the first 3 questions. No idea. Don't panic. Just do the rest of it because something's going to come out in the wash. Okay? Or some of you couldn't care less. Yeah.
How many questions?
I don't know. Something that's reasonable to do in a 1 class period. And it is on the computer, so I need you guys to have your school issued Chromebook. Don't bring a personal laptop. I need your school issued Chromebook. Okay? All right. So today, not what I wanted, not what I wanted. Here. In your groups, I want you guys to talk to each other, take notes on it. What does it mean, or how do you find the domain? How do you determine the if any poles exist, where are they? So, get notebooks out, talk to your neighbors, and then I'm going to have you guys put up on the board, the scribe is going to write down, how do we do that? You know which one we use?
Yeah.
Did we just write?
Yeah, that's what I'm just gonna write ocean study guide questions. I'm just gonna write the title. Right. Sorry, what is the back? Back but then you said it that way.
basically it's equal to its opposite, which is negative f of which is negative x. But it's not. Yes, it's equal to its. No, it's equal to its inverse. But when you just plug in the x, you don't get the same value. Because remember how when we were doing discontinuities, like we had to like prove that three things were equal. That it's not a discontinuity. Yeah, it's that discontinuity.
I didn't realize that was from this. That's from like last topic.
You're right. Okay, I'm talking about. Okay, you're right. I'm talking about the wrong topic.
Well, I don't know. Because he learned that 2 topics ago, but I don't know if he wants that information.
Yeah, you're right.
Well, then how? But you might be right. I don't know how.
Okay, oh, to the whole is the you know those factors that the one that cancels out.
I still haven't written the first one.
So, guys, I am putting things up around the board. Group 1, I want you to say the steps to finding the domain over there. Group 2, I want you to tell us when you can, hello, so group 2 is you guys. I want you to tell us how do you just recognize that a hole exists. Group 3, I want you to tell me how do we find the x value of the hole. And write it on the board over there. Group 4, how do we find the y value of the hole. Group 5, how do we find vertical asymptote? Group 6, how do we find horizontal?
And then we plug in, that factor.
To the equation without the hole, like without with the canceled out factors. Because if you plug it in value, you have to do it.
To the normal equation without the.
Yeah.
Can we say like the rest of the equation? Like we plug it into the rest.
Yeah, or maybe like the fifth.
The fifth, I think it's better to say the rest. Okay, so.
Second, I don't know. So like that's what you want with what? October?
Yeah. With the counselor dude, who's going to talk about
Okay, I'm on it. Sorry, I was ready. When does a rational force?
So there's a hole when the denominator and numerator share a common factor.
Yeah.
There's no way to say so. You just have to like, you don't even have to complete the goal. You just have to demonstrate that you're like doing.
And now we're doing
Yeah, we got
So to find the coordinates, we said.
Sorry, what did you say for the first part? Because you worded it well.
Okay,
It was a whole exists.
a hole exists
When a common factor between
when there's a common factor, when there's a common factor shared between the numerator and the denominator.
Okay, so, Scribe, Adeline, Group 1, can you put up how we would do the domain? Scribe for Group 2, Raul, can you put up how we determine if a hole exists? Virginia, Group 3, how do we find the x value of where the hole happens? Group 4, Griffin, can you tell us how to find the y value? Group 5, Hamal, can you write up how we find vertical asymptotes? Group 6, Bella, can you write up over there how we find horizontal asymptotes? Group 7, Isla, can you tell us how we find end behaviors? Group 8, oh, Lorenzo, it's you. It's destiny. Can you show us how to find a slant asymptote? Group 9, hang on, Byron. Can you show us how to find x-intercepts? That's over there. And group 10 would be Ella. Can you show us how we find y-intercepts? Okay. Yeah. Take the pass.
You might want to say in the numerator and denominator. Like share common factor. That's what we do.
Okay, question.
Like keep that instead of so the numerator and the denominator. Oh, you said that. Oh, I didn't see the numerator. You're
The
good.
numerator and denominator.
Yeah. Sorry. Hey, what about your favorite like real class?
That's a real class. I'm gonna say Slants, but you would say that's not what.
Oh, but we have like a debate.
Child development. We teach the little kids
No, and they're like whenever it's like, hey, what if it's Saturday night and like, I don't really have any plans and like, I don't know, I just want to leave it open.
little girl today, and she's like,
But I have no
makes and it's like I'm supposed to like write like a whole like fucking testament on everything that she does, but she doesn't really do anything. She has like basically nothing to say. Like she just like sits and looks around. She like actually pays attention when people are talking.
So I might just it's like the perfect like
Tomorrow I'm gonna have to learn to die.
Is that what it's?
but
And then I have to plan my lesson. It's fun though. Yeah. There's like levels. Like there's like no. But there's like different periods. Like there's five. I haven't read before.
so it's scary because it's like all
Yeah. I get one lesson.
All right, guys, some people are writing books on the board. I love it.
The thing is, I
Okay.
do stuff too.
I don't want to.
So, write down whatever you need, but some of you have notebooks closed. I recommend that they be open.
No, those are in front of us. Those are not.
So, how do you determine the domain of a function? It says exclude all values that would make the denominator 0. Perfect, I agree. First step, find where all the places that the denominator is 0, which there's some math involved in that, maybe some factoring. When does a rational function have a removable discontinuity? Raul is writing a book. The numerator and the denominator share a common factor. We find the coordinate by setting that factor equal to, okay. So first thing he says, factor the numerator and denominator. And if there's a factor in the top and bottom that match, you have a whole. That was all he had to say, but he said a lot more. Okay, so you answered questions 2, 3, and 4, but thank you.
You said, how do you find one?
Yeah.
Okay, you just had to say, look, in purple it says, a whole exists when the factors match. Group 3 had to find, how do you find the x value? So the factor that matches in the top and bottom, that Raul was pointing out, set that factor to 0. And then you find the y value by plugging the x coordinate into the leftovers, into the reduced function. Yes. Kamal says vertical asymptotes, the x value of the numerator and denominator. What do you mean by that? How do we find vertical asymptotes? that's a horizontal, vertical asymptotes. So, Ray or Anastia, how do we find vertical asymptotes? Okay, kind of. So once reduced, once we take the wholes out, looking at the leftovers, when the leftovers are 0, and I should say leftovers in the denominator. Set those to 0, and that's how you find your vertical asymptotes. And horizontal asymptotes. Okay, that's, so horizontal asymptotes, Bella says, if it's bottom heavy, the horizontal asymptote is y equals 0. If it's top heavy, she wrote y equals none, meaning there is no horizontal asymptote. And if the highest exponent in the top and bottom are equal, you take the coefficients in front of those. So Kamal, I think you have vertical and horizontal swap. So you take the coefficient in the highest exponent in the top over the highest exponent in the bottom, and there you go. End behaviors, graph the function and see where, and find intercepts and or holes. No. End behaviors. End behaviors are whatever the horizontal asymptote was. If the horizontal asymptote was y equals 0, then left end and right end behavior as x goes to positive and negative infinity is also 0. Slant asymptotes. Lorenzo says, if it's top heavy, you divide the denominators, polynomial division. Oh, we'll ask you to show us how to do that in a minute. You're all over and I can help. Find the x-intercepts by setting y to equal to 0 and then solving for x. And y-intercepts, you set x equal to 0 and get a number. Okay, yes. Oof. Things to study for Wednesday. This sheet should be completed. Here's the key. It is posted. Here is worksheet 1, and we've completed it. We should have completed it. The blank and the key is posted. Here is worksheet 2. You were supposed to do problem 1 and 4A for homework. I'm kind of thinking that didn't happen, but let's do number 1 on worksheet 2 now. Can you guys get worksheet 2 out? Eddie, you have a worksheet? Teddy, do you have worksheet 2 or is that worksheet 1?
Whatever's in
All right, guys, first step. Gray? First step is find the denominator. They say find all the places where the denominator is 0. So Eden, how do I find where the denominator is 0? Yeah.
I didn't.
How does this factor? Eden says that's how it factors in the denominator, and so she's following the directions that said exclude all the places where that's 0. Okay, Raoul did a lot of work up there to tell us how to find holes. Holes is where there's a factor up top and on the bottom that match. Unfortunately, that means I need to know how to factor 3x squared minus 16x plus 5. Can anyone tell me the steps to do that? Gray, you got it?
So first up, like, I don't know, I split it into 3x and x. So I make like two parentheses things, so one is 3x, and then at the front, and the other one is x, and then I think about,
Okay, hold on. So, to explain why he's saying that, it's high school, we're not gonna be that mean, usually. What two nice numbers multiply to be 3x squared? Probably the 3x and the 1x.
Yeah.
Okay, cool. Now,
and then so I look at the last thing, and I have to think about factors of that, and then the only, it's prime, so it's 5 and 1. So I have to think about where that can fit in. So, and I know that 3 times 5 is 15, and then plus another 1 is gonna be 16. But
Okay.
it's negative, so.
okay, hold on. So he's saying, again, it's high school, it should factor to be nice, because if it's factors like x minus 7/13, and like, that's just rude. We're not gonna do that. So he said 5 is prime, so it's 5 and 1.
Yeah, but it's negative 5 and negative 1.
Okay, the signs match this, they're both going to match, and they're gonna match that, so he says they're negative, and he said this outside part, outside times outside, 3x times negative 5 is that negative 15x. Inside times inside, that's negative x, that added together to be the middle thing, so he's got it. So, Gray, this is how I factor. I call it factoring by Zen, because you kind of just get a feel for it. But there's reasons why you had a feel for it. Well, the outside, I need a big number. I needed 16 in the end. Okay, so, there it is factored. If you need factoring help, see Gray. Yeah, sorry. All right, so Raoul said, once it's factored, look to see if there's anybody that matches. So Stuart, does this equation have a hole?
Yes.
Where does it have a hole? Where?
5.
At x equals 5?
Yes.
Okay. I agree. So someone else over there said the location of the hole happens where the factor that matched equals 0. So where does x minus 5 equal 0? At x equals positive 5. And then whoever did number 4 said plug that x coordinate into the leftovers. Here's the leftovers. Aiden, how do I plug the x value into the leftovers? What does that mean?
Plug 5 in the
So in the circled pink stuff or this stuff over here?
circle.
Pink stuff, okay. So 3 times 5 minus 1 over 5. So the y value of the whole is that. Like, are you guys okay with this process? Stuart, how you doing? Been a long day, I know. But did your dog throw up on your bed at 2 in the morning? I'm not kidding, so it was very unpleasant. Okay. Vertical asymptotes. So, we don't have a good description on the board. Dante, how do I find vertical asymptotes? What am I looking at?
You take the leftovers, you find the denominator, cut it, put it.
Okay, take the leftovers and find when that denominator is 0. That denominator is just x, so the vertical asymptotes, I have 1, it's at x equals 0. All right. Horizontal asymptotes. Bella told us top heavy, bottom heavy equal. Maya, is this problem top heavy, bottom heavy, or equal?
This problem is,
Equal. Yeah. Because the highest exponent is x squared. So, Nora, what is the horizontal asymptote for this problem going to be? Thank you. So, if you say 3, Delta Math's gonna mark you wrong, and so am I. You need y equals 3.
I thought I got the answer wrong.
So, and where did we get 3 from? The number in front of those highest exponents.
You divide the top.
Yes. So the x squared on the bottom doesn't have a number written in front, but it's implied to be a 1. And then end behaviors. End behaviors are wherever the horizontal asymptotes are. Someone other than Dante who's getting it. Adeline, what are the horizontal asymptotes, or sorry, end behaviors in this question? Okay, in this question, the limit as x goes to positive infinity and negative infinity, the function's gonna go to 3. Because that's what horizontal asymptotes and end behaviors, they're the same thing. Whatever you got for horizontal asymptote is the end behavior also. Slant asymptotes. Gordon, do we have any slant asymptotes here? No. If you have a horizontal asymptote, you do not have a slant. Next thing, x-intercepts are found when y is 0. So, Teddy says x-intercepts are found when y is 0. Do I take the original function, the factored function, or the reduced function, or doesn't it matter?
Reduced.
Reduced, yes. So when is this reduced function right here equal to 0?
I think it was like 1/3.
Yes. So when it's a fraction 0 is when the top is 0. Okay? So finding that, we get that x-intercept, and over here it says y-intercepts are found when we set x equal to 0. Greg?
Like for that one, so when you set x equal to 0, there's a 0 on the bottom, so there's no y-intercept.
Okay, so Gray just said he plugged 0 into the leftovers and got -1 divided by 0. What is -1 divided by 0? Doesn't exist, thank you. All third period was like, it's 0! No, like we had to get out calculators and type it in.
Yeah.
And they're like, why didn't it work? Oh, please. Thank you. There are no y-intercepts. All right, so for your quiz on Wednesday and for your district assessment on Friday, you need to be able to do these things. You have the steps written on the board. Hopefully you have them written in your notes for the second time, because we should have written them in our notes last week on Wednesday. Now, Wednesday you will also have to graph. My recommendations, the steps to graphing. First off, plot any coordinates that you were given or that you calculated. At 5 and 14/5, there's a hole. Create the hole. Put that dot, open circle, make sure it's clear that it's an open circle there. Then, x-intercept, 1/3, comma 0, and then put in your horizontal and vertical asymptotes. Vertical at x equals 0, horizontal at y equals 3. And this side, I have enough information that I can plot the line. Yes, Sanjay?
How accurately do you have to graph?
I need at least 2 coordinates on each side of the asymptote. Okay? And right now, I don't have any coordinates on the other side. So that's what this is for. Pick some x values over there. Okay, a number this side of the asymptote. Zara, what is an x value on this side of my vertical asymptote? Yeah, x is -1. Plugging in -1, it's easier to plug into the leftovers. negative 1 times 3 minus 1, negative 4 over negative 1, positive 4. Okay. Boop. Dot. And I said you gotta find at least 2. All right. Plug in negative 2. Negative 2 times 3 is negative 6, minus 1 is negative 7. By negative 2, that's 7 halves, which is 3 1/2. And so Dante, from there, now I got 2 dots. They're not great dots, but they're dots. I know what asymptotes mean. So I'm gonna go through this dot and have it approach the asymptote that way. And then I'm gonna have this approach the asymptote that other way. That's about as accurate as I need it. Some of you did the complicated problems. If there's 2 vertical asymptotes, we will not ask that on Wednesday. There is one on here. And there was one on the last worksheet that people were like, wait a second, how would I know that? This was an honors question, but we wanted 2 asymptotes, 2 vertical asymptotes for you to see what happens. And there appears like it touches the horizontal asymptote. What? It's allowed to do that. Horizontal asymptotes, all that means is at the end of time, it settles down and does this predictable thing. This guy, the predictable thing is the y value eventually goes off to 0. Right here, it has its wild, crazy teenage years, has the experiences of the full range, literally negative infinity to positive infinity of numbers. But then around like 7 or 8, it's like, all right, settles down, gets a dog that throws up on your bed at 2 in the morning, and rides off into the sunset at a y value of 0. Laura? Did you guys have to know how to do this? No. Do you need to be able to do the wings on the left and the right? Yes. Laura, you're still giving it a look. What's the question?
Not on for question, I was just looking at I was doing the vertical line test and the horizontal line test.
It passes the vertical line test, it does not pass the horizontal line test. So it is not 1-to-1. But I want to see, Lorenzo, can you do how to calculate the slant for us? Yeah, can you do 4A? Okay, so you guys also, for Wednesday, you need to be able to find a slant asymptote. So, here is the process. The thing on top is inside the little chunk, and the thing underneath goes out on the side. Oh, it doesn't, hang on, I got you. It's a challenge. Okay, there you go. So the process is, how many times does x divide into x squared? X amount of times. Then he says, x times x is x squared. X times 2 is 2x. Ooh. This is why I need other people to do it, so I can like nitpick on some stuff. Okay. All right, so where did these things come from? How many times does x go into x squared? X amount of times. And then he took x times x to get x squared, and x times 2 to get positive 2x. And my convention, so that like old-timers disease doesn't kick in too early, change the signs of both of them and add down. So x squared minus x squared, that became 0. Then negative 8x minus 2x is negative 10x. So Lorenzo, it wasn't, I mean, I know what you did, but you didn't really show that you were subtracting out x squared. And then he brings down the 4. Then the next question is, how many times does x go into negative 10x? Negative 10 times. Negative 10 times x is negative 10x. Negative 10 times 20 is, or times 2, is negative 20. And then again, my convention, change the sign and circle it like he did here. Change the sign and circle it like he didn't do there. Adding down, that's a 0. 4 plus 20 is 24. So here's the thing so that you don't get it wrong on delta math, should you need to do this. That is the equation of your slant asymptote. And some of you are going to be upset like, oh, but man, what happened to the leftovers? You know, the remainder. When you get to calculus, that's going to matter. Here, I don't care. Visually, what it means is reset. Nope, can't do it. It means, does it look like the red and the blue line are approaching each other once we go out here? In the middle, it doesn't. This is the wild and crazy teenage years. But out here, they're close. What is that remainder? The remainder is how far away the blue line and the red line are at that x value. So this end behavior, really want this to behave. What's the end behavior? Where's the blue line going as x goes to infinity? Positive infinity. Where's the x value going as we approach negative infinity? Okay, so end behaviors are different. This one didn't have a horizontal asymptote. Up there, when we put up the description of what are the end behaviors, I said it goes wherever the horizontal asymptote goes. This one, that horizontal asymptote went like this. It wasn't horizontal, it was a slant. So Dora, are you okay with this, that the end behavior of this goes to positive infinity? Because it follows wherever that straight line goes. Geometry, you guys are okay with straight lines? You know how they work? Ray's like, yeah, sure, no problem. Roll's like, yeah, it's not an issue. Some others are like, not okay with this. Okay. Can you guys try from the worksheet part B? Part B is this one. So Lorenzo showed you pretty good technique. Can you guys do B?
Was it maybe just in a matter of squeezing them together? Like,
Alright, for the equation of numerator
So the neighbors are like.
-7
I love this band. But then like just 10, I love it. It's not like that. It's like right with this. Like something about it, like
Oh, that's when you take it there.
So there's a common denominator and then there's
Do you have X plus 7? Okay, I get it.
Okay, I mean, you got in this house.
like big graph and tests. That would be like hard to hold. I know, I just don't want to. Let me just draw one.
Alright, guys, so your homework, guys, your homework is to finish worksheet 2. So, and just to show this quickly, guys, the bell did not ring. Maya, first step, what do I do? How many times does 3x squared divide evenly by x? 3x times. 3x times x? 3x times -1. And then Lorenzo, I'm going to clearly show that I'm changing the signs and adding down. Those go away.
Yeah, but when you
-2x plus 1. How many times does x go into -2x? -2. Change the sign and add down. Alright, did you guys get that? Do I care about the remainder? No. What's your question?
Yeah, you were showing me the slope, it's on here.